Which topic has been completed in your class previously?
In chemistry, sir.
Yeah, in chemistry.
Mhm. Chemical reactions and equations.
No, no,
Acid
in
base.
metals. Okay, acid, base, and salts. You have completed. Okay, so
Metals and
Property of
non-metals.
ionic compounds.
metals and non-metal is going on. Carbon compound has also been completed.
No, sir. Property of ionic compounds.
Properties of ionic compound has been completed. Okay, okay. So in metals and non-metals, the chapter has been completed, or still it is going on?
It's still like going on.
Still it is being on. Okay, okay. So may I ask you a few questions regarding to that one? Okay, so because it is a, I'm just going to check whether you have. Okay, let's start studying. So may I know the definition of what is metal? What is metal? What is metal? Or which elements will consider under metal? Is there anyone? Hmm?
Yes.
What are metals? Okay, tell me, what are metals? What are metals? Tell me. Is
Metals.
there anyone? Hmm.
Yes, sir. They
Do you
are.
know?
Yes, sir. They are hard substances. They are. They are solid. Most of them are solid.
Most of
So
them are solid.
yeah, and they
Okay,
are like they are hard, shiny, and ductile,
okay,
flexible, malleable.
okay. So let me explain you that what are metals. Okay, actually, there are some substances that occurs in the nature. Okay, and we call them elements. What we call them? Elements. What are
You can
elements?
also say that they are condensation of minerals, right?
Yeah. Okay. So if I'm asking you that what are elements? So elements, you can say that an element is a substance, that consists of only one kind of atoms. Okay. This is the definition of an element. Okay, what is an element? That there are different kinds of element that you have been studied. Okay, like sodium, potassium, calcium, magnesium, aluminium, zinc, iron, tin, and moreover you have also studied that oxygen, nitrogen. Okay, there are so many different types of elements that you have previously studied. Okay, so regarding to these elements, what is an element? I am again explaining you that a substance that is going to have only one kinds of items. Like for example, if I'm saying that this is a strip of iron, okay, this is a strip of iron. Okay, another one is a strip of like calcium. So they are the same strips, but what is the difference between these two? That the atom of iron is different from the atom of calcium. Okay, like if I'm making that it is circular, for example, and another will be x square shape. Okay, so they are not actually square shape, but I'm just going to explain you this one, that these are not going to that iron, the atom of iron and calciums are not same. Okay, so different elements have different kinds of atom. We can say that different elements have different kinds of different kinds of atom. Okay, now on the basis of these kinds of atoms, we have divided the elements into three main categories and broadly into two. Okay, we have divided mainly into two categories. One is metal, another one is non-metal. Yes, these elements on the basis of kind of atom they have. Okay, on the basis of kind of atoms, these element has been divided into How much type? They have divided into broadly into two types. One is metal, and another one is non-metals.
Non-metal.
Okay. It is metalloids also, but we are not considering here because in this chapter we're going to study only metals and non-metal. Okay. Now, what is the difference between the types of atoms of metals and non-metals? Okay, let's understood the structure of atom. Okay, so this one is nucleus, this one is the shell, first shell, second shell, third shell. Okay, this one is third shell. Okay, so if this is the third shell, so you need to understood. Okay, first shell, this one is second shell. This is going to have some particular kinds of atoms. Okay, and thereafter another shells may have. Okay, so there are different types of shells in a particular atoms, but what we need to understood here is that in metals the number of electrons are what are, this is a subatomic particle of an atom. This is the nucleus, and around it the electron revolves. Okay, the electrons revolves. Okay, 1 2 3 4 5 6 7 8. Okay, so if I'm saying that these are the metals, okay, on the basis of the number of electrons we can consider the different types of atoms. Okay, if I'm saying that an atom with with electrons in its outermost shell. Okay, an atom with electrons in outermost shells, and maximum it can have one or two or three. Okay, if an element is going to have one electron, two electron, and three electron in its outermost shell, then we will consider it as metal. We will consider it as metals. So what is the definition of a metal? That an element, a substance having one or two or three electrons in their outermost shell is considered to be as metal. And the elements which is going to have 4, 5, 6, 7 electrons in their outermost shell will be going considered to be as non-metals. Okay, let's explain you what is non-metal. That if I'm saying that another element that I'm going to give you, that what is the definition of non-metal? Non-metal, an element having 4 to 7 electrons. 4 to 7 electrons in its outermost shell will be considered as non-metal. Okay, non-metal. So this is the definition of metals and non-metals. Okay, for example, if I'm saying that sodium is a metal and chlorine is a non-metal. Why I'm saying this chlorine is a non-metal? The electronic configuration of sodium is 281 and the electronic configuration of chlorine is 287. So it is going to have one electron in its outermost shell and it is going to have 7 electrons in its outermost shell. So here the number is 7. So it is a non-metal. Okay. And this one is we can say that this one is going to have one electron in its outermost shell. This will be considered as metal. But there is an exception. In case of helium, I'm going to say, I have written here that those atoms that is going to have 1 or 2 or 3. But in case there is an exception of hydrogen and helium. Hydrogen is going to have one electron in its outermost shell, but it is neither considered as metal nor non-metal. And helium is going to have 2 electrons in its outermost shell, and it is considered to be as it is not considered as non-metal or metal. It is a noble gas. So let me explain you one more time. Okay. That exception here is hydrogen and helium gas. Okay, helium gas has 2 electrons in its outermost shell 2 electrons, and hydrogen is going to have 1 electron in its outermost shell, but it is not metal. They are not metal. Not metals. Now you understood the definitions of metals.
Yes, sir.
You understood that what are metals? Vidwan, Ammar, Madiha. You
So like, but
understood?
like, so like when you are, if you are
Yes.
like writing it down like in a, like a what, like a, like if you are describing it, like if they ask in a question way, like how do you write it?
May I know what do you think? Please repeat.
So like if they,
Defining
if
metal.
in the exam, if they ask like this, okay, how do you like, like
Okay.
define it?
Okay. The question that you're going to get. Okay, let me explain you that how are you going to get these questions regarding to this one. The definition of that, these are physical properties of metals, that these are simple physical properties of metal, that they are sonorous, they produce sound and striking, they are conductor of electricity. But the actual definitions of metal is that they are going to have 1 or 2 or 3 electrons in their outer shell. So how which means let me know that how you're going to get the questions regarding to this. Okay, let me gives you here is some questions that I'm going to gain electrons. For example, this is the question number 30. Okay, question number 30. The electronic configuration of element X, Y, Z's are given this one, this one, this one. Which of the following is metal? So how will you consider on the basis that if you don't know that the number of electronic configurations in this one? So how will you be able to answer this question if you don't know that the number of electrons in the outermost shell of an atom is the electronic configurations of metals and non-metals? Okay, so it is being given to you that here it is X. Okay, X substance, whether it is a metal or non-metal, let me tell me. It is going to have electronic
Non-metal.
configuration 2, 8. Okay, 8. If it is 8, then it is neither metal nor non-metal. Okay, okay. So it is being
Okay.
either the, okay, because why? Because it is a noble gas. It is noble gas. Okay, noble gas. Okay, except helium, all noble gas is going to have 8 electron in its outermost shell, except helium. Except helium. Helium is going to have 2 electrons in the outermost shell, and it is a noble gas. Okay. Now, why? This one is this question, why? Okay. So this is electronic configuration 287. Okay, 287. So tell me whether it is a metal or a non-metal by element. Tell me.
Non-metal.
Yeah, it will be considered to be as non-metal. Why non-metal? Because it is going to have 7 electrons in its outermost shell. If it is going to have 4, 5, 6, or 7, 4, 5, 6,
Non-metal.
7, then it will be considered to be as non-metals. Tell me whether Z is metal or non-metal.
That is metal.
Z is metal because it is going to have 2 electrons in its outermost shell. If it is going to have 1, 2, or 3 electrons, then it is considered to be as metal. Okay. In the outermost shell, you need to check only the outermost shell, but except the helium and hydrogen. The electronic configuration of helium is only 2, and that of hydrogen is only 1. Got it? So this is not. Got it?
Yes.
Okay. So let's move to the next questions regarding to the same topic. Okay. This one is question number 29. Can you tell me? Question number 29. What should be the answer for this question? The reaction between X, Y, the reaction between X and Y form means when X react with Y, it form a compound Z. X loses electron and Y gains electrons. Which of the following property is not shown by Z? Tell me. Which of the property will not be shown by Z? Rizwan, Amma,
Option. The option B.
option,
B. Second one.
option, Option B, it will going to have low melting point. Okay.
Will not going to have
Acha, will not
low
going to have,
melting.
will not be shown. Why? Why?
Because it will going to show high melting point.
Why? Okay, let me explain you this one. Okay. Let suppose I'm going to explain you this one. This is a sodium metal, okay? And this one is chloride, okay? So this one is X. Let consider this one is Y. X loses electron because it has an electronic configuration is 281, and that of chlorine is 287. Okay. Now this one electron is going to be lost by sodium. Why? Because sodium wants this stability. Why? Because sodium wants stability. So why it is losing its electron? Because it wants stability. For example, if it's lose one of its electron, like 2, 8, okay, then it will lose one of its electron and will comes to the nearest noble gas electronic configuration and will become stable. Every atom in the universe wants the electronic configuration to the nearest noble gas. Like for example, helium has an electronic configuration of 2. Neon is going to have electronic configuration is 2, 8. Argon is going to have electronic configuration of 2, 8, 8. So every noble gas wants the electronic configuration, sorry, every elements wants the electronic configuration to the nearest noble gas. For example, this is sodium. This will lose one of its electron. Why it will lose one of its electron? Because why it will lose one of its electron? Because it wants the electronic configuration to the nearest noble gas in order to attain this stability. Similarly, this chlorine wants to gain one electron. Why? Because it wants the electronic configuration to the nearest noble gas, that is that is argon. Okay, so it will, when it gain one of its electron, it form 2, 8 electronic configuration, and when it loses one electron, it will comes to this 2, 8 2, 8 electronic configurations. So what would happen? Two, after losing one of its electron, the sodium will become Na positive. Why it will become Na positive? Because it has lose one of its electron. When electron is negatively charged, when it loses, then atom is electrically neutral. But when you remove the electronegative charge from it, then it will become positively charged. And similarly, when chlorine get one of its electron, one electron, extra electron from sodium, then it will become Cl minus ion. Okay. Now, what is the difference? What happens here? It is stable now. It is also stable now. There is should not be any. But why they will come closer to each other? Why? Because of the strong electrostatic force of attraction. It has given. It is not the sharing bond like in HCl. HCl. What would happen in the HCl? This is chlorine, 7 electron in its outermost shell, and this is hydrogen. Okay. This is 2, 8, 7 electronic configuration, and hydrogen is going to have 1 electronic configuration, only one. So what would happen? Hydrogen will not give its one electron to chlorine. Why? Because at 0, hydrogen is not stable. The hydrogen nearest noble gas is helium. Helium. So it wants that it should have 2 electrons in its outermost shell in order to attain this stability. So it will not completely lose its electron. Like sodium loses its electron here. Why? Because it will, after losing one electron, it will gain this electronic configuration to the nearest noble gas. But here in this case, in case of hydrogen, if hydrogen loses, it will become 0. So it will not lose. It will share one electron. In case of sharing, what would happen? In case of sharing, what would happen? Simply,
Just to confirm.
it will it will share this like this, like this. It will share electrons. Okay. So this is the type of sharing. Okay, this is sharing. Okay. So what would happen here is that when you share this electron here, okay, so hydrogen is going to have 2 electron for some time, and this chlorine will going to have 8 electron for some time. So both are stable, but this is a covalent bond because one electron is being participated here. Okay, so this is a covalent bond. But in case of sodium and chloride ion, they are stable. They have completely loses their electrons. Now they are stable. Okay, so what would happen here is that if this is a, yes, sir. Beta, wait a minute.
Okay, sir.
Okay, beta. So let's understood this one. Okay, let's understood. Now you understood, beta. Hello.
Yes, sir.
Okay.
Yes.
So what we were discussing here, that here in case of hydrogen, there is sharing. They are not separated out because they are still sharing their electron. But in case of sodium, they have losing. Now why it is the sodium is happy, chloride is also happy that the final sodium has completely given one electron to the chloride, and chloride ion has already accepted, chlorine ion has already accepted the one electron. Then why they are closer to each other? Because of the strong electrostatic force of attraction. And you know that the strong electrostatic force of attraction, or we can say that electrostatic force of attraction is 10 raised to the power 48 times greater than gravitational force. Gravitational force. Okay, you know that this
No,
force is
sir.
so high. This force is so high that this will not allow these ions, Na positive ion, Cl minus ion, to move freely. Because it has given one electron, it has got plus one charge, and it has loosened one, gain one electron, it has got negative one charge. Now they are what they are doing, they are held together with strong, very strong force of attraction. Okay, and this is 10 raised to the power 48 times higher. Okay. Okay, now coming to the question. Okay. So so we can say that the reaction between X and YZ compound loses one electron and one gains electrons. Okay, so metal loses electrons and Y gains electron. It is a non-metal. Okay, now let me ask that if X loses electron and Y gains electron, which property will not be shown? Which why? You can say that they will not going to have low melting point. Why? Because a large amount of force of attraction will be required. Okay, to separate them out, because they are held together, tightly held together with a strong electrostatic force of attraction. Got it?
Yes, sir.
Got it. Now you can consider this one. They can conduct electricity in molten state. In molten state, they can conduct electricity. To know that ionic compounds can conduct electricity in molten state. Occurs in solid. Why they occurs in solid state? Why? Because of the force of attraction, strong force of attraction between the positively and negatively charged ions. And next one is that is high melting point. They are going to have high melting point. So this one is the incorrect. Okay, I understood. Okay. Okay. So let me ask you two or three questions. Two more. So your metallurgy topic has been completed or still it is being going? Hmm? Okay. So can you tell me what is the difference between an ore? Can you tell me what is the difference between an ore and gang?
What's it?
What is the difference between? Let me write here. What's the difference between an ore and mineral? Mineral. Hmm? What is the difference between ore and mineral?
So like ore is the like a condensed version of minerals.
Mm-hmm.
The ore means it contains raw metal inside it. And
And
minerals are
what are minerals?
minerals we get from
Earth crust. Ores क्या होते हैं? नहीं समझ आया? So what are ores? Let me explain you. That there are some substances, okay, that occurs naturally in earth crust. Okay, ores are the substances that occurs naturally in earth crust, or this you can say that there's some minerals, there's some substances like sodium, potassium, okay, that occurs naturally in earth crust. Okay, and this one, these are called minerals. For example, that I'm going to say that sand is also a mineral. Okay, sand, silica, that contains some iron, okay, some metals, some aluminium, some silicate iron it is going to have. Okay, so this is a mineral, but there are some substances from which the metal can be extracted economically. For example, if I'm saying that ore, what is an ore? That I'm going to give you an example here, that what is an ore. So if I'm saying that Al2O3 dot 2H2O, this is an ore. This is an ore of iron. Okay, and sorry, ore of aluminium, from which you can extract it, from which you can extract aluminium. Okay, aluminium. But if I'm writing here an example of Al2O3 dot 2H2O dot 2SiO2, okay, dot 2SiO2. So this one is not an ore. This is not an ore. Not an ore. Why I'm saying this? That this one is ore, this one is ore, this one is not. The major difference. What is the major difference?
SiO2.
SiO2 is silica oxide,
Okay.
silicon oxide. Okay, this one is silicon oxide. Okay, so what are ores? Ores are those minerals from which you can economically extract out the metals. Okay, they are called ores. What are ores? For example, if I'm giving an example of that, you are going to pick metals, or I'm going to give you a sand. Okay, sand, or I'm going to, like, for example, I'm going to give you a banana. Okay, and I ask you that please extract iron from it. Okay, so you will start extracting iron from it. Okay, will you be able to extract? And if I'm going to give you an example, something that is made up of like I'm going to give you a substance that is made up of iron. Like, for example, if I'm going to give you a substance, like I'm going to give you a bicycle or a car, and please extract the iron from it. So will you be able to extract more iron from banana, or something like substance that is already made up of iron? So you will definitely be able to iron, the substance from which you that is going to have more percentage of iron. Okay, and you can easily be able to calculate. So similarly, ores, what are ores? Ores are those substances from which metal can be extracted out economically. Yes, without using much effort, without using much money. For example, if I'm going to extract out metal, aluminum metal Al2O3 dot 2H2. Okay, this is a bauxite. This is bauxite. Another one is Al2O3 dot 2H2O dot 2SiO2. Okay, this one is China clay, and this one is bauxite ore. Okay, why I'm saying this is an ore? Because when you extract aluminium metal from this one, it will be cheaper, easy, and convenient for you. But when you are going to extract out aluminium from this one, it will be more, it will take more efforts, more money. It is not economical. So that's why we will reject this one. This will not be considered as ore. So what is an ore and what is a mineral? Mineral is any substance that is going to have some metals. For example, this is also a mineral. Okay, this one is also a mineral. But the mineral from which you can easily economically extract out metal, okay, that will be considered as ore. So this one is ore, but not mineral. Sorry, this one is mineral, always also an ore. But this one is only mineral. This one is only mineral. Only mineral, but not an ore. Okay, got it? You understood?
Yes, sir.
That what is the difference between an ore and a mineral?
Or
Okay.
easily to extract.
Any substance that is going to have some metals or metal-like substance in it that occurs naturally in earth crust. Okay, that is called minerals. But from those minerals from which you can extract out metals economically, profitably, that will be considered as, we will consider it as how? We will consider it as mineral. Okay, got it? Got my point?
So
Okay.
in China, in China clay, we can extract metal, right?
Yeah, you can extract it. You can extract the aluminum from China clay also, but this is not economical. For example, if you extract the aluminum from China clay of a market value of 20 rupees, for example, I have given you and market value of 20, but you have spent 30 rupees on it. So will it be economical for you? No. Okay. If you are spending 30 and only getting 20 back, so it will not be considered as economical for you. So, but in case of bauxite, if you are spending 10, then you are getting 20. Okay, so this will be considered as economical. So this is the difference between an ore and a mineral. Okay, so let me ask some more questions from this chapter also. Okay, have you studied the electrolytic refining, electrolytic reductions, and other topics? Refining, have you studied? Calcination, roasting, have you studied?
Balancing.
Not balancing. From this chapter, I'm going to ask you only.
This chapter, I will learn till that 3.1 properties of
Okay.
ionic compound.
You were just only studying the properties. Okay. Okay. Have you studied properly the acid, bases, and salts? This chapter.
Yes.
Okay. So let me ask you some questions from regarding to this one also. Okay. You have just only studied the ionic properties. Okay. So have you studied salts from acid, bases, and salts? Acid,
Yes, sir.
bases, and salts. Okay. So let me
Yes, sir.
revise, ask you some 2 or 3 questions from that one also. Okay, because this is just an introductory class today. We will continue the topic, but let me ask you some questions from that topic also. Okay, so what is actually a salt? Can you tell me what is actually a salt? Or what is acid? What is base? What is an acid?
It is an in the pH table. It represents
Value lower than?
Acid are normally sour in taste.
Yeah, this is the physical property. But what is the definitions of acids?
In the pH value, they have
Yeah, they are going to have low pH value,
low pH value and
less than 7. Okay.
yeah, but they have more H plus ions concentration.
Yeah, they have more H plus ion concentration. Let me ask some question. If I'm going to have some, I'm saying this one is NaOH. Okay. This one is base. Do this have H plus ions also when you are going to have
Yes.
NaOH?
But
Yes, sir.
it has low number of H plus ions.
Yeah, we're going to have the low numbers of H plus ions. So let me explain you what is acid and what are base. There are 2 different scientists who have explained this acid, bases, and salts. Let me explain you this definition also. What are acids? Acids, one scientist has given this Arrhenius. According to Arrhenius, acids are those substances that dissociate H plus ions in aqueous, in water. Okay. And bases are those substances that dissociate OH negative ion in aqueous. Okay. And there is one other scientist, that is Bronsted-Lowry. Bronsted-Lowry. What he said? He said that acids are those substances that donate. Acid are those substances that donate H plus ions. Okay. And bases are those substances that accept the H plus ions. Okay. So let me consider that what are acid and what are base. Okay. This one. For example, if I'm just going to take an example, okay, that like I'm going to take HCl when added to water, H2O. Okay. So when you add it to water, then it will form hydronium ion, H3O positive. Means it will donate it H plus ions to this water and will form hydronium ion and will form Cl minus chloride ion. So according to Bronsted, this HCl is losing H plus ion. It will be considered as acid. And it is accepting the H plus ion. It will be considered as base. Similarly, if I'm giving example of NH3, tell me whether NH3 is acid or base. There is one question that ammonia do not contain. It is generally asked in the examination that ammonia do not contain any OH negative ions. Still it is characterized as base. Still it is characterized as base. Why? Can you see that ammonia is NH3? How can you say that it is characterized base? So how will you write this answer? How will you explain this? This is the 10th standard examination question, and it is so many times been asked in the examination that ammonia do not contain any OH negative ion. There is no, you generally say that base is made up of NaOH like MgOH whole twice, okay, like COH whole twice. But ammonia is not ammonia is not going to have OH negative ion, and still it is characterized as base. Why? Why it is characterized as base? Can you tell me? When you add ammonia to water, I'm going to write water like this. Water is H2O. You can write water as HOH, H2O. Okay. So what happened when ammonia is added to water? It accepts the H plus ion from water and form NH4 positive and this OH minus ion. Water itself break into H positive and OH minus ion. Okay. So ammonia is that substance that is accepting the H plus ion. And here HCl is a substance that is donating the H plus ion. So according to Bronsted-Lowry concept, if it is accepting the H plus ion, it will be considered as base. And here the water is donating, it is considered to be as acid. So in the above case, water is acting as a base. Here it is acting as an acid. Okay.
So OH is acid.
Hmm?
So OH will be acid.
The OH will remain as like this one, though it when it accepts the H plus ions. So the properties of acid is due to H plus ion. Na? Properties of acid is shown by H plus ion. H plus ion. When the concentration of H plus ions, like I'm going to give you some example that if I'm having 10 water molecule, H positive and OH minus ion, H positive and OH minus ion, H positive and OH minus ion. Okay, H positive and OH minus ion, H positive and OH minus ion. And if I add ammonia to it, let I'm going to give adding some ammonia molecule here, NH3, 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 NH3. Okay. So what would happen here? Before ammonia, ammonia is not added. The acidic behavior and the basic behavior of water is same. Means the one, there is one H plus ion, one OH negative ion, then it is acid, and this one is base. So it will neutral. It will consider to be as neutral. The, the number of H plus ion and OH negative ion is same. So it will be acid as well as base, equal in amount. Okay. But when you add ammonia, ammonia will start eating this H plus ion from water. Okay. It will start eating this one and forming NH4 positive ion. So what would happen? The concentration of OH ion will increases in the solution. There will be more number of H plus ion will increases. So the basic behavior will also increase. The basic behavior will increase. Okay. Got it? You understood?
So we'll say that as a acid.
Hmm? Yeah.
So
So we will say that simply the ammonia, since the ammonia accept the H plus ion from water, it will be considered as base. Or we can say that when ammonia is added to water, it accepts the H plus ion and thereby increases the concentration of OH negative ion. Here the concentration of OH negative ion will increase. That's why it's make the solution basic. Okay. So whether a substance is going to have OH negative ion or not, it may be it may also act as a base. Okay. And if a substance is going to have OH, like for example, if I'm going to have ethanol, C2H5OH, there is also another question in the NCERT that ethanol when added to water, it will not accept the H plus ion nor it will lose the H plus ion. So it will remain same as C2H5OH, C2H5OH. Okay, it will remain same. So here ethanol is neither accepting the H plus ion nor losing the H plus ion. So it will not be characterized as base or an acid. It will not. It will remain same. Okay, got it?
so it's not a base nor a acid.
No. Neither it is acidic
So
or it is basic in nature. Still,
it will be
it has
neutral.
like OH. It has. Huh?
So it will be neutral.
Yeah, it will be neutral. It is neither acidic nor basic. Still, it has OH, but it is not releasing its H plus ions or OH negative ion. So that's why it is not neither considered as acid nor it will be considered as base. So it is an NCERT question that ethanol and glucose. Ethanol is C2H5OH, C2H5OH, and glucose is C6H12O6. Okay. Both when added to water, they are not characterized as acid. Why? Because they do not either they neither loses H plus ions nor it accept the H plus. So thereby it is not considered as base or an acid. They remain same in its original form. Okay. Everybody understood?
Yes, sir.
Amar understood? Hashid?
Yes.
Okay. So this you need to write in some other classes. I will give you. But let me discuss some other questions also regarding to this topic, because today is an introductory class only. That's I'm going to clear you some concept. Okay. So now tell me again what is the definition of an acid and a base? Hmm?
So they dilute with H plus ions in aqueous solution.
Those substances that dissociate H plus ions
Sorry, dissociate.
in aqueous, it will be considered as
Acid.
and if it is accepting the H plus ion, it will be considered as
What's that?
base. And if it is accepting the H plus ion, accepting the H plus ion, it will be considered as base. Okay. Okay. Okay, tell me This question number 21. What should be the correct answer for this one? What should be the correct answer for this one? 2 ml each concentrated HCl HNO3 and a mixture of HCl HNO concentrated. They are mixed in 3:1. Taken in the test tube, level as 1 to ABC. A small piece of metal is put in a test tube. No change is color, but metal got dissolved in C respectively. The metal could be. What do you?
PT?
PT is platinum.
Oh.
Okay, tell me this one, that what would happen when substance like HCl and concentrated HNO3 are mixed in a ratio of 1:3. What will be formed? And what is the name of that mixtures? What is the name of that mixture? That is aqua regia. Aqua regia. Okay. Aqua regia is a substance or a mixture. Aqua regia. Okay, what is aqua regia? Aqua regia is a mixture of concentrated HCl and HNO3. When these two are mixed together in a ratio of 3:1, you must notice this one, that the ratio of means HCl should be taken in 3 times, and to that the amount that HNO3 has been taken. Means simply HCl should be 3 times. Means if you are going to have 3 test tube of HCl and 1 test tube of HNO3, then they are mixed together. It will form aqua regia, but it should be concentrated, and it is used to dissolve metals, generally gold and platinum. Okay, gold. Okay, mainly gold. So it is being added 2 ml of HCl HNO3 in a test. We have taken this one in a concentrated. But you know that. Let me explain you here. If you have test tube A, and it is going to have concentrated HCl, and the test tube B, okay, B, and it is going to have concentrated HNO3, and the test tube C, okay, and it is going to have concentrated HNO3 HCl and HNO3 in ratio 3:1. Means it is going to have aqua regia. So when you add some metals into this one, nothing will happen, because generally the metals are low reactive metals and they do not react with acid like gold, platinum. Similarly, in case of HNO3 also. But in aqua regia, it is also called royal water. And in this, it get dissolved. It can easily dissolve. Okay. So in royal water, aqua regia, okay, gold or platinum can easily be dissolved, and we can simply say that that metal should be mainly gold, okay, and platinum also, but here we will give the preference to the gold. Okay, so it is being asked that the metal could be, AU is gold. Okay, so write it down in the copy that aqua regia, the ratio of aqua regia is 3:1, and write it down. Done. So now you understood what is metals and what is non-metal. Okay, here's one question. There is a chemical properties of metals. You have studied the chemical properties of metal. Have you studied this one? Chemical properties of metal. Okay. So I'm going to discuss one important question from you. That you know that metal, when added to acid, it gives you what? Tell me.
Salt and water.
Salt and
Water. Hydrogen.
hydrogen gas. Okay. What is the terms and condition? For metal and acids? Do all metals react with acids?
No.
For example, if I'm writing copper when react with dilute HCl, what would happen?
No change.
No change.
No
Why?
change. Because
Why? Why no change?
because yeah. HCU has no react. No.
You can simply say that because copper is less reactive than copper is
Yeah, less reactive than HCU.
copper is less reactive than hydrogen. Okay. So let me explain you one more thing here. Okay. There are some exceptions for this one, that is HCl that I'm writing here. Metals when react with acids, they form salt plus hydrogen gas. Okay. Do non-metal also react with acid? Non-metals? Do non-metals also react with acids?
No.
To produce salt and hydrogen gas? Why? If yes, then why? If not, then why? If it is being asked that why do non-metals do not react with acids? We generally keep acids in those containers which are not made up of metals. Why do metals do not react? Sorry, non-metals do not react with acids. So let me explain you this one. That I have already taught this one, that non-metals are those elements that are going to have 4, 5 or 6 electrons. Non-metals are those substances that is going to have 4, 5, 6 or 7 electron in their outermost shell. Okay, everyone please concentrate here. Okay, so they are going to have 4 or 5 or 6 or 7 electron in their outermost shell. What are they doing actually? They are electron deficient. They generally gains electrons. They don't lose their electrons. They generally gains the electron. For example, if I'm going to take the example of nitrogen, nitrogen electronic configuration is 2,5. It will not lose its 5 electrons to gain the electronic configuration to the nearest noble gas, that is 2. But rather than it will gain 3 electrons. 3 electrons to form the electronic configuration to the nearest noble gas and will form N-3 ion. Like for example, sulfur, electronic configuration 286. Okay. Yes, beta. So if I'm going to give you sulfur, this is 286. Electronic configuration of sulfur is 286. So if you are, means this is sulfur is electron deficient. Sulfur is electron deficient. Okay, electron deficient means non-metals cannot donate the electron, they generally gains the electrons. They generally gains the electrons. So if I'm going to give you an example here that this is SCl, like I'm going to give you SCl, when react with sodium, it form NaCl plus hydrogen gas. So what is happening here? Let me explain you. This is H plus ion. This is another H plus ion. Let me balance the equation. This one is balanced. So there are two HCl molecule, then there will be two chloride ion, and there will be two sodium ions. Sodium. The electronic configuration of this one is 281. This one is also 281. What would happen here? That sodium will lose one of its electron and will give it to this one. And again, it will lose one of its electron and will give it to this one. And this will form hydrogen atoms with one electron. What is the difference between H plus ion and hydrogen atom? The H plus ion do not have electron, but this one is going to have one electron. Hydrogen is going to have, hydrogen atoms is the atom with one electron. And hydrogen gas is formed by gaining electrons. What is the structure of hydrogen gas? This one is the structure of hydrogen gas. When two hydrogen atoms combine together with one electron, they form a molecule of hydrogen gas. So the H plus ion from acids get the electron from metals, because metals are electron donator. They are going to have one or two or three electrons, so they can easily lose electrons. One electron, two electron, three electron to gain the in order to attain the electronic configuration to the nearest noble gas. Okay, but in case of non-metals, non-metals are electron deficient. For example, if I start reacting this hydrochloric acid with sulfur, it will not form SCl2 plus hydrogen gas. It will not form. Why? Because the electronic configuration of this one is 286 and this one is also 286. It will not lose its electron like metal was giving the electron to the hydrogen ions to gain one electron. So non-metals are electron deficient. Non-metals are electron deficient. They will not be able to lose electron. They don't like, they will not lose, or they will not give the electron to the H plus ions of acids. H plus ions of acids. Okay, to form hydrogen gas. So in order to form the hydrogen gas, H plus ions of acid require electrons, and these electrons requirement can be only fulfilled by metals that can easily donate electrons. But non-metals do not lose electrons, they gain electrons. They are electron deficient, they gains electron. For example, this chloride ion 287, it will not lose electron, rather it will gain electrons, will form 288. Like sulfur 286, it will not lose, it will gain, form 288 electronic configuration. So non-metals are electron deficient, they will not be able to add electron to the H plus ions of acids. That's why non-metal do not react with acids to form hydrogen gas. Got it? That's why we kept the substance acids in the non-metal substance, okay, plastics or something, because they are not able to give the H plus ion to the they are not able to give the electron to the H plus ions of acids to form hydrogen gas. And without electrons, H plus ion will not form into the hydrogen atoms. Hydrogen atoms में form नहीं करेंगे, and that's why. Got it? समझ आया? तो ये this one was, you can simply understood that. And non-metals are then electron deficient. They are not able to donate electrons to the H plus ions of acids. That's why they don't produce hydrogen gas. Only metals. Okay. Got it? So that's all for today. Okay. We'll meet you in the next class. Okay. So remember, we have not written anything in the class. Why? Because it is just an introductory class, but when we continue, When we will continue, then we will going to write each and every topics. Like we have the slides, like I'm going to show you here. Like we have slides here, and we generally write. Here it is, like this, like this. We usually write each and everything. Okay. But right now, this was just an introductory class, so I won't allow anything to you to write. Just to clear doubts. If you are going to have any doubts, you can ask. You have any doubt? Any one of you? Regarding to any chapters, any topic in chemistry? Amar, Vidwan, do you have any doubt?
Yes, sir.